Have you ever stopped to think about how many everyday objects rely on zinc? It may not be as famous as iron, copper, or aluminum, but zinc plays a crucial role in modern life. From protecting bridges and skyscrapers against rust to helping your immune system stay healthy, this remarkable metal is everywhere. Despite its importance, most people know very little about it. So, what exactly is zinc, and why has it become one of the world's most valuable engineering materials? Zinc is a chemical element with the symbol Zn and atomic number 30. It is a bluish-silver metal that naturally occurs in the Earth's crust, usually combined with other minerals rather than in its pure form. The most common zinc ore is sphalerite, a mineral rich in zinc sulfide. After mining, the ore is processed and refined to produce the pure metal used in thousands of industrial applications. Humans have been using zinc for thousands of years, even before they fully understood what it was. Ancient civilizations unknowingly mixed zinc-containing ores with copper to create brass, an alloy that was stronger, easier to shape, and more resistant to corrosion than pure copper. However, zinc was not officially identified as a separate metal until the 18th century, when scientists began isolating and studying its unique properties. One of zinc's greatest advantages is its incredible resistance to corrosion. When exposed to air, zinc quickly forms a thin protective layer of zinc oxide and zinc carbonate on its surface. This natural coating acts like a shield, preventing oxygen and moisture from attacking the metal underneath. Because of this self-protecting behavior, zinc is widely used to protect steel through a process called galvanization. Galvanization is one of the most important applications of zinc in engineering. During this process, steel is coated with a thin layer of molten zinc. If the protective coating is scratched, the zinc continues protecting the steel through what engineers call sacrificial protection. Instead of allowing the steel to rust, the zinc corrodes first, extending the life of structures by decades. This is why galvanized steel is commonly found in bridges, power transmission towers, road guardrails, pipelines, roofing systems, fences, and countless construction projects around the world. Beyond construction, zinc is also widely used in manufacturing. It is an essential ingredient in brass, an alloy made from copper and zinc that combines strength, corrosion resistance, and an attractive golden appearance. Brass is commonly used in plumbing fixtures, musical instruments, locks, electrical connectors, decorative hardware, and industrial equipment. Zinc is also used in die casting, a manufacturing process where molten metal is injected into precision molds to produce complex parts for automobiles, electronics, appliances, and machinery. Another fascinating use of zinc is in batteries. Zinc serves as an electrode in many battery technologies, including alkaline batteries, zinc carbon batteries, zinc air batteries, and several next-generation energy storage systems currently under development. Researchers are particularly interested in zinc-based batteries because they are safer, less expensive, and more environmentally friendly than some lithium-based alternatives. Zinc is also an essential nutrient for the human body. Although only small amounts are needed, zinc plays a vital role in hundreds of biological processes. It supports the immune system, helps wounds heal, contributes to healthy skin, and assists enzymes responsible for growth and metabolism. Foods such as meat, seafood, dairy products, nuts, beans, and whole grains naturally contain zinc. However, while zinc is essential in small amounts, excessive exposure to industrial zinc dust or fumes can be harmful, making proper workplace safety extremely important. From an environmental perspective, zinc offers another major advantage. It is highly recyclable. Unlike many materials that lose quality after repeated recycling, zinc can be melted down and reused again and again with minimal loss of performance. Today, a significant percentage of the world's zinc production comes from recycled sources, helping reduce mining activity and lowering the environmental impact of manufacturing. As industries move toward cleaner technologies, zinc continues gaining importance. Engineers are developing zinc-based batteries for renewable energy storage, corrosion-resistant coatings for offshore wind farms, and innovative materials for sustainable construction. Because zinc is abundant, relatively affordable, and highly recyclable, many experts believe it will remain a critical material for the future of engineering and clean energy. So, what makes zinc so special? It isn't the strongest metal or the lightest, but its unique combination of corrosion resistance, versatility, affordability, recyclability, and biological importance makes it indispensable. Whether it's protecting a massive suspension bridge from rust, powering a battery, strengthening an alloy, or supporting your immune system, zinc quietly works behind the scenes every single day. The next time you see a metal fence, a highway guardrail, a steel bridge, or even replace the batteries in a remote control, remember that zinc is likely playing a hidden but essential role. It may not receive the same attention as other engineering materials, but without zinc, much of the modern world would simply not last as long or perform as reliably.